You type a question into ChatGPT and get a paragraph back in 2 seconds. It feels instant, it feels cheap, it feels like something that should cost almost nothing. So why is OpenAI reportedly losing billions of dollars a year? Why did one AI company spend over $100 million just to train a single model? Why does every major tech company on Earth suddenly need to spend tens of billions on infrastructure? The answer involves physics, logistics, and some genuinely uncomfortable economics. And once you understand it, the price of AI stops looking like a business problem and starts looking like a hard constraint. Start with what AI actually runs on. Modern AI models run on GPUs, graphics processing units. The name is misleading. These chips were originally designed for rendering video games, but it turned out their architecture was almost perfectly suited to the kind of math that machine learning requires. Millions of simple multiplications running simultaneously, in parallel. NVIDIA figured this out before almost anyone else. Their H100 chip, the workhorse of the current AI boom, costs around $30,000 per unit. A serious AI training cluster might use 10,000 of them. Do the math. You are looking at $300 million in hardware before you've paid for a single building, a single power line, or a single engineer. And GPUs are just the beginning. The training problem. When you hear that a model was trained, what actually happened is this. Engineers fed the model billions of examples, measured how wrong its predictions were, and adjusted billions of numerical parameters to make it less wrong. Then they did this again and again for weeks or months. For weeks. A large training run requires holding the entire model, sometimes hundreds of billions of parameters, in fast memory simultaneously. That memory has to stay synchronized across thousands of chips at once, which means the chips have to talk to each other constantly over connections that move data at hundreds of gigabytes per second. Getting all of that working without a single chip failing, without a network bottleneck, without a software bug corrupting the run, and doing it for weeks straight is genuinely difficult engineering. When something goes wrong, you don't just lose an hour, you can lose days. The result? Training a frontier model costs somewhere between $50 million and several $100 million, depending on scale. That's not a price that will ever fall to zero, because each new generation of model trains on more data, with more parameters, on more chips. The memory wall. Here's something that most people miss when they think about AI costs. The bottleneck isn't just raw compute, it's memory bandwidth. Every time the model generates a single token, it has to read its entire parameter set from memory. For a large model, that might be hundreds of gigabytes of data, moved every single time, for every single word it writes. The problem isn't that the chips can't do the math. It's that the chips spend most of their time waiting for data to arrive. This is called the memory wall. Chip designers have known about it for years. It's one of the deepest reasons why scaling AI is expensive in ways that don't simply get better as processors get faster. The inference problem running a model for users, Inference in the jargon, has its own cost structure. Every query you send to ChatGPT, Claude, or Gemini costs the company a small amount of money. The estimates vary, but even fractions of a cent per query add up fast at the scale of millions of users. OpenAI reportedly had over 200 million weekly users by early 2025. If even a fraction of those users send several queries a day, the daily compute bill is enormous. And most of those users are paying either nothing or a flat monthly fee that doesn't scale with their actual usage. This is the core tension in the AI business right now. The product is genuinely useful enough that millions of people use it constantly, but the cost of providing it scales with every single request, while the revenue often doesn't. The energy problem, there is one more cost that rarely appears in tech coverage, but is increasingly hard to ignore: power. Training a large language model consumes roughly as much electricity as hundreds of homes use in a year. Inference at scale consumes even more in aggregate because it never stops. The servers run 24 hours a day, and they generate so much heat that data centers need industrial cooling systems just to keep them from melting. Tech companies are now signing power purchase agreements in the gigawatt range, the kind of deals that require building new power plants. Microsoft, Google, Amazon, and others have publicly discussed wanting nuclear power specifically because AI's energy demand is too consistent and too large for renewable sources alone to handle reliably. This is not a software problem. It is an infrastructure problem. and infrastructure takes years to build. So why is AI expensive? Because every step of it, from the chips to the training runs to the serving infrastructure to the electricity, operates at a scale that has no cheap version. It will get cheaper over time. It always does. Chips improve. Software gets more efficient. Models get smaller and faster without losing capability. OpenAI's own pricing for API access has dropped substantially over the past few years, and that trend will continue. But there's a limit to how cheap it can get, because there are physical limits to how efficiently you can move data, convert electricity into computation, and dissipate heat. The economics of AI are not like the economics of software, where copying a file costs essentially nothing. Every inference takes real energy, real memory, real time. The other thing worth sitting with. The companies building these systems know all of this. They are spending the money anyway, not because they have solved the cost problem, but because they believe the thing being built is valuable enough that the costs will eventually make sense. Whether they're right about that is probably the most important business question of the decade. If this kind of explanation is useful to you, there's more on the channel. We cover how AI training works, what the context window actually is, and why AI chips are designed the way they are. Subscribe if you want the honest version, not the hype.